Hello, I am Pete Demar with Battery Research and Testing, and I will be narrating this session of our stationary battery maintenance Tech Tips. This is Tech Tip number 4, Benefits of Catalysts in VRLA cells. In this Tech Tip, we are going to explain how a catalyst functions and how their usage in VRLA cells is a benefit in a number of ways. All VRLA cells, whether their electrolyte is immobilized in a gel form or if it is in the AGM, absorbed glass mat form, must be saturated to function properly. This means they must be moist to function properly. All lead acid cells, whether they are the vented or valve-regulated kind, give off gas. Yes, VRLA cells are designed to recombine the gases inside themselves and thus maintain proper saturation of the AGM or gel. However, the efficiency of this recombination process is not always as efficient as desired, and the cells do give off gas. This means that the gases exit the cells without being recombined back into water content as required. Because of this ongoing problem, they eventually end up in a dried out condition. While they are in the process of drying out, the AGM or gel continues to shrink, and compression and contact between the plates is reduced or lost. This is easily observed by the changing of the internal ohmic values over time. This is why someone that is familiar with and understands this condition can look at a snapshot of the internal ohmic values and have a good idea of the severity of the dryout for that particular model. The numbers just cannot lie. They are what they are at that particular moment in time. They also cannot improve on their own. The only way that cells that dry out can be recovered is for a resaturation to be performed. This is a rather straightforward process with the AGM design cells. The IOVR Plus process that is used to recover AGM cells is explained in Tech Tip number 3. This type of recovery process also is explained in the IEEE 1188A 2014 document, and they call it a special recovery process. Every manufacturer will acknowledge that when a cell becomes dried out, that it will not perform properly and will be at a much higher risk of thermal runaway. It needs to be understood that all manufacturers want to build the best batteries that they can within the restraints of their business operation limitations, of course. No one deliberately wants to build junk. They all want repeat sales. Because of their understanding of the importance of maintaining adequate moisture in the cells and keeping the plate groups properly polarized, a number of manufacturers are now installing catalysts in their VRLA cells as part of the manufacturing process. There are two primary benefits that having a catalyst in the headspace of these cells will provide, and both are equally important. When installed proactively, which means before the cells have decayed, the catalysts help keep the negative plates from becoming undercharged. Think discharge, which lowers the overcharging of the positive plates, while at the same time they help recombine the gases that are always being generated when any cell is on charge back into water. This keeps the cells properly saturated. A third benefit, which is usually not discussed, is that by keeping the AGM or gel saturated, is that it slows down the transport of the oxygen from the positive plates to the negatives. Plus, some of the oxygen is trapped as dissolved gas and is prevented from getting to the negatives. There are some manufacturers that have cells or units that are specifically designed and marketed to be used in much hotter environments than normal, and they include catalysts in those cells in order to prevent that early in life dryout. Remember, dryout equals the kiss of death of the cell or unit. With cells that did not have catalysts installed early in life and which have dried out or started to dry out, the first thing needed to fix that is that they need to be properly resaturated. That needs to be done first in order to reestablish the contact and compression. Then a boost charge needs to be applied to help correct the polarization of the plates, and then finally a catalyst needs to be added to maintain that moisture and recovery. Without going into the history of the many years of research from manufacturers and scientists from around the world back in the 80s and 90s, when everyone's VRLA cells were drying very early in life, I will simply state that the research led by Will Jones of Philadelphia Scientific discovered the primary root cause of the premature failure of VRLA cells and subsequently developed a catalyst that fits into the headspace of the cell. This corrected the basic problem causing this early in life dryout and PCL, premature capacity loss. That breakthrough discovery continues to this day to benefit users anywhere. The very first battery manufacturer to install these catalysts in their VRLA cells was C&D. This is what the original C&D catalyst-equipped vent assembly looked like. This is the actual Teflon wrap catalyst used in those cells. This is the capsule that is inside that Teflon, and it held the catalyst materials. As you can see, it is pretty much the same material as many flame arresters. The end that is sealed is to keep the recombination materials inside it. Once we at BR&T understood the benefits possible from having a catalyst in a VRLA cell and learning that only C&D had these available then, we contacted Philadelphia Scientific to discuss producing a unit that would fit into the GMB Absolute cells. Back then, GMB had the lion's share of the VRLA market, and we serviced many users of their batteries, and we understood the substantial PCL occurring back then. Our initial attempts at recovering those cells was published at BATCon 1997 and was before we knew about the invention of that catalyst. We are an independent stationary battery service company, which simply means that we do not, nor ever have represented any battery manufacturer, and we only work on stationary battery systems. Our goal is to provide the users we work for with the best service and battery knowledge possible. We realize that if we included a catalyst in the headspace of cells that we were resaturating, that we could provide a long-term benefit to the cells and the user. These were the first two prototypes ever made that were designed to fit in the Absolute 1 cells. As you can see, the hook, bayonet fitting, is right close to the vent opening. This was the location of the hook in the Absolute 1 cells. The Absolute 2 cells all use a deeper fitting. These prototypes were fabricated in 1999, as is evidenced by the 99 on the Teflon coating. As can be seen, the catalyst is the same Teflon wrapped one as in the C&D cells. During the development of this unit, GMB changed their location of where the vent actually hooks inside the cell. So Philadelphia Scientific developed a body that would work in both the Absolute 1 and the Absolute 2 units. This was the eventual design of the vent body itself, and as can be seen, it has the ability to be used in both the older Absolute 1 cells as well as the Absolute 2 units. At that time, it used a plastic pin to hold the catalyst in the vent body. What was not understood at that moment in time, but was learned later, is that there was an issue with the Teflon wrap catalyst, in that there was no way to limit how much gas would be recombined, and therefore no way to control just how hot these units could get. As can be seen from these two C&D vent bodies, they could get very hot and the plastic could melt, and bad things could and did happen. Once this issue was discovered, the catalyst body was redesigned and the amount of gas able to enter the cylinder was limited. This is sort of like a governor on an engine. You can have all the fuel you want available, but it will only burn so much. Not a very scientific explanation, but hopefully you can follow it. This is what it looks like. As you will see later, all of the different microcat models use that same cylinder type design, but in varying sizes. And dependent upon specifics, the amount of filtering and material also will vary. This is an original uncontrolled C&D assembly on the left, and the same vent with the new microcat on the right. These are various versions of the improved CTL-009 model with the encapsulated microcat. These fit all absolutes, plus over half of the Enersys models. This one here fits the newest design C&D cells. These all fit the Enersys cells that the CTL-009 does not fit, plus a number of European manufacturers' products. This one fits the Nerada cells. This one fits the East Penn Deca cells. These are some different vent body designs that were developed that fit a variety of manufacturers' requirements. And last but not least are a variety of catalysts that fit differing requirements. As can be understood, we have a wide range of catalysts available for a wide range of sizes and manufacturers' products and application. We think that we may have catalyst-equipped vents for the vast majority of cells being produced anywhere. With most 2-volt cells, it is a relatively simple process to remove the old vent and to install a catalyst-equipped one. Takes maybe 30 seconds each. Hopefully, this tech tip helped provide a little better understanding on this subject. If you would like to read the science behind these, let us know and we will either send them to you or direct you to where they are located. If you are interested in understanding more about what we do or how we might be able to help you, please go to www.batteryresearch.com and look around. If you would like to be notified when we release a new tech tip, please go to info@batteryresearch.com and tell us to notify you when we release a new one. Or if you just have a question on a stationary battery subject, do the same. Oh yes, if you have any experiences or pictures of unusual things that you have found, please share them with us so that all of us in this industry can benefit each other. Have a great day, stay safe, stay healthy, and thank you.